Okay, now we're doing 8.2, the product and quotient of functions. The first question says, find the product and quotient of following algebraically. State any restriction on domain, asymptotes if it exists or holds. And f of x equals root x minus 1 and g of x equals 0.5x minus 2. The first one, A, find f of x times g of x equals h of x. Then so you just sub in the value 4, and remember, if you've seen the review sheet, it told you how to solve a product of function algebraically. So you just multiply both functions, and then that's what was done here. And you don't have to simplify to 0.5x root x minus 1 minus 2 this, but you can just leave it as this. And in this case, there's no restriction on domain, so the domain is x is an element of all real numbers, and for the domain of product of functions, there's never a restriction. So, and then B, f of x over g of x equals g of x. So then you just see root x minus 1 over 0.5x minus 2. So in this case, there will be a restriction because there's also a restriction on the quotient of functions. So because only if the function is just one number, like g of x equals 1 or something. So in this case, our restriction is x cannot equal -4, cannot equal +4, sorry. So you gotta see how we did this. 0.5x minus 2 equals 0, then 0.5x equals 2, x equals 4. So then the restrictions is said, and then domain is x such that x cannot equal -4, and x is an element of all real numbers. So for this one, there is no holes, but there is an asymptote. So the asymptote is at +4, sorry, +4, not -4. So okay, and then C, find g of x equals L of x. So same thing, just sub in the value for g of x and L of x, and then that's all you do. In this case, x has got to be greater than 0, because when you do 0 minus 1, that's root of -1. So, okay, so the domain actually is x has got to be greater than 1, because if x is not greater than 1, then you're just going to have 1 minus 1 here, 0, and then the function is going to be undefined. So domain is x such that x is greater than 1, and x is an element of all real numbers. Okay, use the graphs of f of x equals x squared minus x plus 5 and g of x equals x to graph the following. F of x times g of x, so equals y, and this f over g of x equals y. And then so right here I grabbed the function already, and then so this is the quadratic function f of x, and this is the linear function g of x. And so when you this is the graph of the function, so you just basically take the values of y. So for this one, y is 0. So for this one, y is equal to 0 for g of x, and for this, y is equal to 5. And when you divide them, it gives you 0. So then, and the same thing here. At this point, it's 1, and at this point, it's 5. So divide both sides, it gives you the value of 5 also. So that's just basically all you do, and then so we see the function just comes at f times g of x. So and then multiplying this, doing this, dividing f of x over g of x. So first we know this, let's just take this point first. So we know f divided by 0, 5 divided by 0 is undefined. So that means we're gonna have an asymptote. So right here x equals 0. So there's the function is not defined right there. So then you just take the values of this, and then you just divide, do the same thing, the opposite of what you did here, and then gives you a rational function of this form. So the blue function is the multiplication, the product, and the black function is the quotient. And then we have the domain of both. So domain of f times g of x. So domain is x such that x is an element of all real numbers, and the domain of f divided by g of x is such that x cannot be equal to 0, and x is an element of all real numbers. Okay then.